Let's jump right in and decode the hidden building blocks of chemistry, all right? You see, chemistry isn't just dry chalkboard equations. It's the wild, dynamic study of how everything connects. Our starting point is matter. It literally builds everything, from solar systems to a simple glass of water. Zooming in, solids lock particles into a rigid, vibrating crystal lattice. It's kind of like a microscopic grid. Add some heat, and boom, that rigid lattice melts away, letting particles flow freely as a liquid. Crank up the heat even more? Particles scatter completely, expanding wildly to fill up their whole container. Crazy enough, matter sometimes skips the liquid phase entirely. We call this sublimation, like dry ice vaporizing. So how do we actually classify all this? Is it a pure substance or a separable physical mixture? To find out what makes up those pure substances, we gotta zoom way down to the atomic level. Inside every atom is a super dense core. It's a nucleus crammed with positive protons and neutral neutrons. Far outside that core, tiny negatively charged electrons are just buzzing around in probability clouds called orbitals. To map these chaotic clouds, chemists use 4 specific quantum numbers, detailing their exact energy and shape. Atoms can actually gain or lose outer electrons to become charged ions, either positive cations or negative anions. With so many crazy atomic variations out there, how do chemists keep track? Well, they look for patterns. Elements get grouped by properties. You've got shiny metals that lose electrons and brittle nonmetals that gain them. The periodic table neatly organizes them into vertical families with similar behaviors and horizontal periods by atomic mass. But atomic stability isn't guaranteed. Deep inside the nucleus, sometimes that binding glue simply fails. If a nucleus gets a lopsided neutron-to-proton ratio, it goes unstable and triggers a violent, spontaneous radioactive decay. When that messy breakup happens, it usually triggers one of 3 natural emissions: alpha, beta, or gamma. Kind of like tossing cargo overboard, alpha emission ejects 2 protons and 2 neutrons to stabilize heavy elements. Beta emission is way wilder. A neutron literally transforms into a proton, shooting out a high-speed electron. Then there's gamma emission. It's pure, massless energy blasting out intense radiation alongside other types of decay. You even have rare modes, like spitting out a positive electron, or a nucleus consuming its own electron. From a glass of water to the violent splitting of an atom, what secrets will you decode next?